Hi scholars, today we're going to talk about multiplying binomials and make sense of the procedure, the algorithm, the rules that we use to multiply binomials using the area model. And you've probably had a lot of experience at this point multiplying binomials. This, by the way, is also known as the FOIL method, so everyone has FOILed a lot. And the reason why we're sort of going over it here is that it shows up in a lot of different areas of mathematics. So first off, it definitely shows up when we're talking about quadratic functions. If I want to find out the roots of a quadratic function, I will need to know how to factor it, which relates very closely with multiplying two binomials. This also shows up when we're solving, in some cases, when we're solving radical equations. And these are equations that have a square root in them. And finally, this can show up sometimes when we are solving rational equations as well. And rational equations are equations that have sort of rational expressions in them. So for one example of that could be x squared plus 7x plus 10 all over 2x plus 4, for example. Okay, that's a rational equation. So let's take a look. X plus 4 times x plus 6. So this is a product of two binomials. Each of these terms has, or each of these expressions has sort of two terms in it, an x and a 4, an x and a 6. So one way we can do that, the way you're probably most familiar with, is to FOIL it, right? So we multiply the first, and then we multiply the outer, and then we multiply the inner together, and then we multiply the last together. And that's fine, one way of doing it. And so we can rewrite that as x squared plus 6x plus 4x plus 24, making sure that we've counted everything. And this is x squared plus 10x plus 24. So this is one method, right? Now notice this method right here, it's essentially using the distributive property twice. So let's take a look at, if I have this x, I'm just going to use these different colors here. So if I have an x and then I have a 4 here, right? One way that I can rearrange what just happened is I can rewrite it as saying, well, let me do x times x plus 6, and then I'm just going to add 4 times x plus 6. Oops, use a different color. 4 times x plus 6, right? So it's as if this x, right, will be distributed to the x plus 6, and this 4 will also be distributed to the x plus 6, okay? And when we multiply this out, x times x is x squared, right? X times 6 is 6x. 4 times x is 4x, so it's the same thing. 4 times 6 is 24. This is another way of thinking about why this FOIL method works, right? So to FOIL, right, it's just like, oh, something I memorized, right? But really it makes sense because it's a double application of the distributive property. Okay, now we can also make sense of this sort of thinking about an area model, okay? And what I mean by this is, let's take a look. Here we have a rectangle where one side, here I'll make it a little bigger, where one side is x plus 6 and the other side is x plus 4, okay? And we can imagine that here's our rectangle. It's sort of, we can sort of divide it up where this length is x right here, this is x, and then we add 6 on this length, and then this is x right here, and we add 4 on this length. And we want to find out what is the area of this rectangle, and we can do it by finding the area of the 4 smaller rectangles that make up the larger rectangle and then add them, right? So x times x is nothing more than x squared, right? So if I have x times x, it's x squared. X times 4 is 4x. X times 6 is 6x. And again, these aren't just like numbers that we're doing here, right? 6x is actually the area of this rectangle here. 4x is actually the area of this rectangle right here, okay? So this is why we call it the area model. And finally, 6 times 4. Well, if you have a rectangle with length 6 and width 4, the area is going to be 24, whatever, square units or whatever. And so notice, look at these terms, x squared, 4x, 6 squared, 24, right? Do they look familiar? Yeah, there they all are, okay? There they all are. So these are sort of like three different ways of viewing why this multiplication, when we multiply two binomials, why we really need to make sense of four different terms. Okay? All right, so let's keep going and let's do a couple more examples. X minus 4 times x plus 6. Okay? Well, we can write that as, like, we'll just do this. We can write that as x squared. And my middle two terms, notice they're minus 4x and plus 6x. Okay, that comes from here and from here. And my last term is 4 times 6 is 24. However, we need to make sure that since it's really a negative 4 times a positive 6, it's really a minus 24 here, right? And so we can simplify this as x squared, combine like terms. This is going to be plus 2x minus 24. And I want to call your attention to the fact that our middle term here is positive, has a coefficient of a positive 2. And if I look at the numbers 6 and negative 4, the larger number is positive, right? 6 is positive, and 6 is larger than 4, which is negative. So when a larger number of these two numbers is positive, we should expect to have the coefficient of the middle term, the x term, be positive as well. Let's take a look at what happens here. So here we have something that looks similar, only it's plus 4 and minus 6. So I would expect that my answer, we don't even know what the answer is yet, but I would expect that my answer would be have a negative term, have a negative x term. Okay, negative some number x. So let's do it out. Okay, so x times x is our x squared. X times negative 6 is negative 6x. Positive 4x. Again, minus 24. And this is all going to equal x squared minus 2x minus 24. Okay, this is how we would multiply this binomial. And in fact, we were correct. In fact, since here, negative 6, the 6 is negative, which is larger than the 4 that's positive, this middle term is going to be negative. And let's see what happens if they're both negative. Okay, we can multiply them out. In this case, we're going to get x squared minus 6x minus 4x. And now this last term is a negative 6 times a negative 4, right? That's this last term. That's actually going to be positive 24. Negative times negative is positive. So we can finally rewrite this one as x squared minus 10x and plus our 24. Now in this case, notice that both the negative 6 and the negative 4 were contributing to the fact that this coefficient is really negative, right? It's like we added both those negatives together, which is essentially what we did. And notice always that if they're both negative, if both of these pieces of these binomials are negative, that our last term is going to be positive because of the negative times a negative is a positive. Okay, so let's take a look at the following question, or the following thing in general. In general, we can say that if I have x plus a times x plus b, it's going to equal x squared plus a plus bx plus ab. Oh my gosh, what a mess, what a wreck. I really don't like this. Too many variables, right? This is nothing more than what we said, what we were just looking at, right? So let's take a look at what was our example. What was the first example we did? X plus 6 and x plus 4, right? So let's take a look at that. This is nothing more than saying that x plus 6 times x plus 4 is equal to x squared plus, well, here a is 6, so plus 6 plus, here b is 4, 6 plus 4, okay, is the coefficient in front of the x term, plus a times b, which is nothing more than 6 times 4, okay? 6 times 4, and that is how we would, right, we can write that out as x squared plus 10x plus 24, exactly what we found in 3 different ways before, okay? So this is one of those rules that is maybe not the most useful to memorize in this form, right? But it's very important pattern. It's a very important pattern. And we can also rewrite this pattern on this side as it's sort of like x squared plus the sum of these two numbers a and b plus the product of those two numbers, right? And so this is another way of thinking about it. And will make sense later on of the sum product pattern. This is one way of viewing the sum product pattern.